a square is a rectangle. A square is a very specific type of rectangle. It's when all four sides are equal. So a square is always also a rectangle. So one is always. A rectangle is a rhombus. Well, a rhombus has four equal sides. So a rectangle is only a rhombus when the four sides are equal, making it a square. But this is sometimes. Is a rhombus always a square? Well, a rhombus has four equal sides, but the angles are not necessarily all right. A rhombus is a square only when all four angles are right angles. So this is sometimes. A rhombus is a parallelogram. Well, a rhombus, the opposite sides are parallel, so this is always a parallelogram. It's possible for you to have a trapezoid with three congruent sides. If you had four congruent sides, you'd actually have a rhombus. But if you have three congruent, it is possible to have three congruent sides. So this is sometimes. The diagonals of a trapezoid bisect each other? Never. The diagonals of a rectangle are congruent? They're always congruent. They're always going to be the same length. The diagonals of a parallelogram bisect the angles. This is true when your parallelogram is a square or a rhombus, so sometimes. Okay, I'm going to graph the point negative 5, 0. 1, 2, 3, 4, 5, 0. That's point A. 3, 2. This is going to look weird because this graph paper looks messed up. 5, 6. 5, 1, 2, 3, 4, 5, 6. Negative 3, 4. 1, 2, 3, 1, 2, 3, 4. Again, I think this is going to look a little strange because my graph paper somehow looks a little messed up. But when I graph this, and let me label all the points. Let's see, I have, this is A, B, C, and D. Now, I'm going to show that one pair of opposite sides are both congruent and parallel. So I have to find the slope of this and find the slope of this, and I have to find the distance of this and the distance of that. And that will show that this is a parallelogram. So the slope of DC is equal to, let's see, here's the slope of DC. So I have y2 minus y1, 4 minus 6, over x2 minus x1, negative 3 minus 5, which is negative 2 over negative 8, which is 1 over 4. The slope of AB, here's AB, 2 minus 0 on the top, and 3 minus negative 5, so plus 5 on the bottom. So this is 2 over 8, which is 1/4. Now I've shown that these are parallel. Now I have to show that they're congruent. So DC is equal to the square root of the difference of the x's, 5 minus negative 3, that's plus 3, plus the difference of the y's, 0 minus 2, squared. This is 8 squared plus 2 squared, which is 64 plus 4, which is the square root of 68. Then we'll do AB. This is the square root of, here's my A and B, negative 5 minus 3 squared plus 0 minus 2 squared, which is the square root of negative 8 squared plus negative 2 squared, which is equal to the square root of 64 plus 4, which is the square root of 68. So they're parallel and congruent, therefore ABCD is a parallelogram. Okay, this time we're going to show that this is a parallelogram by showing that the diagonals bisect each other, which means that they have the same midpoint. So let's first draw the diagonals. This is one of them. And this is the other one. Okay. And what we're going to try to show is that this is the same as this, and this is the same as that. All right. So the first thing we're going to do is find the midpoint of AC. The midpoint of AC, well, we have the x value of the midpoint is the x values added up, negative 5 plus 5 over 0 over 2. And the y value of the midpoint is 0 plus 6 over 2, which is 3. So the midpoint of this is 0, 3. And it didn't do a very good job because this graph paper screwed up, but that's the point right there. Okay, now let's look at the midpoint of DB. Okay, the x value of the midpoint is, let's see, 3 plus negative 3 over 2. The y value of the midpoint is 2 plus 4. So that is 0, 3. So these both have the same midpoint, which means that they bisect each other. And because we know they bisect each other, we know that this is a parallelogram.